In the previous session, we had discussed active soil forming factors. So now we'll be discussing passive soil forming. As we had mentioned, the passive soil forming factors include relief or topography, parent material, and time. Now, Glinka had proposed a twofold classification of soil based on origin or genesis, and this was ectodynamomorphic and endodynamomorphic. Ectodynamomorphic implies those soils whose origin is primarily attributed to the influence of climate. That means the soils which are mainly formed due to the action of various climatic elements and their profile characteristics, their various chemical and physical properties are all influenced by climate and reflect that influence of climate, like laterite, podzol, chestnut, these kinds of soils. On the other hand, we have the endodynamomorphic soils, whose origin is primarily attributed to the influence of parent material, and the influence of climate is actually suppressed. As a consequence, the profile characteristics, the horizon characteristics, and the properties of the soil all reflect the influence of parent material rather than the influence of the climate. Renzina soil, which is rich in calcium, is one of very good examples of endodynamomorphic soils. Now, parent material, if we come to the three passive soil forming factors, we're taking up parent material first. Parent material, as we said, if it's more important than any other agent, even active agent like more than climate, then it is called an endodynamomorphic soil. This endodynamomorphic soil, as we said, an example was redzina. Now, parent material can be from different sources. Essentially, what is a parent material? Any consolidated rock whose weathering leads to the formation of soil. That consolidated rock is actually the parent material of that soil. Now, it can be a single material like quartz, or it can be a amalgam of minerals or materials like sand, silt, clay, granite, where a number of minerals are amalgam to form a rock, which is then weathered to form a soil. Right. Now, these parent materials can be residual or residuum parent material, that is in situ, that is the rock or bedrock where it was situated, there it got weathered and it led to the formation of the soil in that region. So if the underlying bedrock is of local origin in situ, then the parent material is termed residual or residuum parent material. But if the parent material is transported from somewhere else and deposited in that region, and then that is weathered and broken down into fragments, and through weathering and soil perogenesis leads to soil formation, it is called transported parent material. These can be glacial if the transported materials are from glacial origin or outwash. They can be aeolian or wind loess if they have been brought over from aeolian areas, marine, uh, if from coastal areas, lacustrine if they are from lakes, they may be lava if they are of volcanic origin, they may be alluvium if they are of fertile plains, and if they are based in high water table areas and where reduction rather than oxidation reactions are more common, then these parent materials are called or termed as cumulose. Now we have to remember that parent material is normally not the predominant determining factor. So often same parent material in different climate leads to different soils. Like we saw in the earlier segment that we did, that laterite and podzol both are formed in aluminium and iron rich parent material based rocks. But the difference is one is formed in hot and humid areas, the other in cool and humid areas. But the opposite is also true if the parent material is different and the climate is same, then also it may lead to the same soil. So parent material also influences other soil characteristics because the amount of calcium or the soluble salts that are there in the parent material directly impacts the amount of acidity. The more the bases or salt solutions, or the acidity is reduced. For example, in limestone, the presence of limestone delays acidity as the calcium is a base reaction. When they fall and decompose, the soil also becomes rich in these calcium bases, and they delay acidity and hence humus formation. This is just a diagrammatic view of the various parent material sources. It may be alluvial from fertile plains, marine, lacustrine, outwash, aeolian, peat from organic origin. So we can have a different ice transported, water transported, wind transported. Those which are transported by gravity are called colluvial parent material. Now, topography also influences the formation of soil in any region, soil profile, because firstly the steepness of the slope is very important, because in plain gentle slopes there is time for water to percolate and result in profile development. So soils are very deep as drainage is good and profile differentiation can happen. But on steeper slopes, water surface runoff is very high, so percolation being limited, horizon differentiation or topsoil subsoil mixing is not present, and thus horizon formation or deep soil formation is not possible. External drainage is more common because percolation is being limited. Besides the slope, the mountain gradient is also important, because mountain top will have less deep soils, because the water will be drained off freely. So water table will be very deep. So this will lead to low organic matter and low salt. But in the valleys also, the drainage will be very poor as the water will accumulate in groundwater table will be near the surface. So pH will be higher and they will be more darker in color, there will be more accumulation. It is along the slopes what happens is different drainage condition prevails at different areas. So a sequence of different soils based on hydrology is formed. This hydrological sequence of soils along the slopes is termed as soil catena, right? And it gives different colors along the slope to the soil, as in different areas along the slope different hydrological and drainage conditions prevail, which lead to different stages of oxidation of the same mineral. So it gives a very different color sequence to soils in some areas. Now, this is more evident obviously in iron-rich slopes, because ferric oxides are red in color. As oxidation decreases, they get more orange in color. So it depends on the hydrological sequence or the amount or nature of drainage along a slope. If they follow a sequence, then this sequence is termed as soil catena. The slope is also important. Southern slopes get more warm sunlight and are warmer, so they have more organic matter formulation. Now, the last parameter or factor influencing soil formation is time. There are 5 major stages of soil formation. Initial stage, when the parent material has not yet been weathered. Juvenile stage, when the weathering starts. The virile stage, when there is decomposition of weathered material has not just started, it has progressed a bit. The senile stage, when the weathering has been accomplished, and the final stage when all the profile development is completed and the horizons can be distinctly identified. This rate of development over time depends on the other soil forming factors, the climate, the organic matter, the topography, the drainage, all these factors. And the age of soil is the stage of soil development, not the time taken. In some places, soil development may be very faster because of very active soil forming factors being there, but in other areas soil forming processes may not be that active. So how much time is not important. What is important in terms of age of soil is its level of maturity. That means how well those horizons have been developed, how much or to what extent the weathering has progressed. So if the soil has been totally formed, which is be termed as a mature soil, all the horizons will be distinctly visible. And the process of soil formation is then called complete. There is a steady state in amount of clay in the soil is in equilibrium with the amount of primary minerals in the soil, and the clay increases with depth. So this is a mature soil scenario. Immature soils are younger soils normally found along fertile plains where every year due to floods there is deposition. So pedogenesis is a continuous process. There is no time for horizon formation, and primary minerals are still formed. There is no time to go to a equilibrium state. So in this way, we have immature soils and mature soils, but time is very important factor, because even if a mature soil, there is no static state. Even a mature soil may get eroded or transported, and parts of it deposited in different locations, which may form the basis for new parent material, and a new cycle of soil formation may start. Or over a mature soil, new deposition may occur and a new cycle of soil formation may start. So even after a mature soil is formed, it is in equilibrium. It is not a static state. It is a continuously evolving process as climate, temperature, organismic activities. These are not static elements. These are also continuously active. So the soil forming process also is not ever fully complete. It is a dynamic process. So soil is also called a dynamic body. This has to be kept in mind, that state of soil is not static, it is a dynamic body, and this will help in turn determine the land use that is suitable for a region today may not be suitable after say 3 decades, because soil formation may have changed the characteristics of the soil. So land use management practices in any region need to be also evolving in that context.